Okay, so for number 15, all right, they're giving you a table and they're saying let k be the function given by k of x is equal to f of x over g of x, where g of x cannot equal 0. And what is the value of k prime at 3? Okay, so this is basically just testing you on the quotient rule. Okay, all right, so k prime of x would equal f prime of x, right? F prime of x times g of x minus f of x times g prime of x all over g of x squared. Okay, so all we need to do is to find k prime of 3. Okay, I'm going to come up here a little bit, so I need a little bit more room, I know. K prime of 3 would equal f prime of 3 times g of 3 minus f of 3 times g prime of 3 all over g of 3 squared. Okay, so what's f prime of 3? So f prime of 3 is 5. So this would be 5 times g of 3, and g of 3 is 2. And then minus f of 3. F of 3 is negative 1. And then g prime of 3 is negative 2. And then back to the g of 3. G of 3 is 2, and we're going to square that, right? 2 squared. So this would be 10, and this would be 2, but we're going to minus, right? So minus 2 all over 2 squared, which is 4. So that would be 8 over 4, which would give you a value of 2. And the correct answer is C. Okay, so C. Okay, so number 16. All right, I'm going to go back to my binder paper. So for 16, they're giving you y is equal to 5x times the square root of x squared plus 1. Okay, and they want you to find dy over dx at x equals 3. Okay, all right, so the best way to do this is to rewrite this. Okay, so this is equivalent to 5x times x squared plus 1 raised to the 1/2 power. Okay, all right, so we have a product here. Okay, so we're going to want to use the product rule to find this derivative. Okay, so dy over dx would equal, okay, so the derivative of 5x would just be 5. So 5 times the second function, which would be x squared plus 1 to the 1/2 power, okay, and then plus, and then 5x times, and now I got to take the derivative of this one, right? So this is times 1/2 times x squared plus 1 to the negative 1/2 power. Okay, and then I got to use the chain rule, right? So I got to take the derivative of this x squared plus 1, which would just be 2x. So times 2x, okay? All right, cleaning this up a little bit, this would be 5 times x squared plus 1. And then here, my 2's are going to be this 2 and this 2, because I'm multiplying by 1/2, and I'm also multiplying by 2, right? These are going to cancel each other out, and you're going to be left with 5x squared. So plus 5x squared times x squared plus 1 to the negative 1/2. So times x squared plus 1 to the negative 1/2. Okay. Well, you know what? Right here, I need a 1/2 right there. Okay. Because it's 5 times x squared plus 1/2. Okay. So this is equivalent to 5 square roots of x squared plus 1 plus, and then this would be 5x squared over the square root. So 5x squared over the square root of x squared plus 1. Okay, now they're asking to find this at x equals 3. So the correct notation for this would be dy over dx, a vertical line, and we write at x equals 3. Okay, so this would be 5 square roots of 3 squared plus 1, and then plus 5 times 3 squared over the square root of 3 squared plus 1. Okay, so then this would equal 5, and then 3 squared is 9 plus 1 is 10. So this is the square root of 10. 5 square roots of 10 plus, and this would be 9 times 5, which would be 45 over the square root of 10. And I'm hoping that's one of our answers, okay? So it looks like it would be D, okay? So the correct answer for number 16 is D, okay? How you write this, okay, I know it's multiple choice, but if you write an unsimplified answer, like I'm gonna tell you the truth, if you write your answer on the AP exam and you write it right here like that, they are gonna count it right, okay? You don't have to clean this up at all. As long as you've shown that you've plugged the 3 in for X, you're gonna get if this is equivalent to the right answer, you're gonna get points, okay? All right, so I just want to tell you that don't spend time simplifying stuff. Just if you've plugged it in, just leave it like that, and unless you need it for something else. Okay, all right. Okay, so let's go to 17. So for 17, they're giving you the limit as h approaches 0 of arc sine of a plus h minus arc sine of a all over h is equal to 2. And what they're telling you here is that this is a derivative. This is another form of asking you for the derivative. Now, what's the derivative? The function is f of x is equal to arc sine. Okay, so my function is arc sine of x. Okay, and they're saying, okay, what's f prime of a? And they're telling you basically f prime of a is equal to 2. Okay, so what is f prime of x? Okay, so a is a specific value that they're telling you this. Okay, so f prime of x. Now, so this is where it's helpful to know your derivative rules, right? So the derivative arc sine of x, now that's the same as sine inverse of x, is 1 over the square root of 1 minus x squared, okay? So that would mean this is the derivative at a, okay? So that means f prime of a would have to equal 1 over the square root of 1 minus a squared. And what I know about this from this is has to equal 2. So we have 1 over the square root of 1 minus a squared would have to equal 2. Okay, so the best way to do this is to get rid of the fraction is, and what I would do is I'd multiply both sides by the square root of 1 minus a squared. So that would result in the left side being 1 is equal to 2 square roots of 1 minus a squared. And then what I would do is divide both sides by 2. So 1/2 is equal to the square root of 1 minus a squared. And then I would square both sides. So if I square 1/2, that would give you 1/4 is equal to 1 minus a squared. Since this is minus a squared, I'm gonna move it to the other side and move the 1/4 to the right-hand side. So this becomes a squared is equal to 1 minus 1/4, which would give you a squared is equal to 3/4. And then you'd want to square root both sides, okay? And when you square root both sides, you would get a is equal to plus or minus, okay, the square root of 3 over the square root of 4, which is 2, right? So a is either positive or negative square root of 3 over 2. And they didn't give you an option of negative square root of 3 over 2. They just gave you the square root of 3 over 2. So it would have to be, the answer to this would be B, okay? All right, so let's go on to number 18. So they're giving you the natural, for number 18, they're giving you the natural log of 2x plus y is equal to x plus 1, and they want to know what dy over dx is, okay? All right, so the derivative of the natural log function is 1 over this, right? Okay, so this is going to be 1 over 2x plus y times, okay, and now we're going to take the derivative of this with respect to x. So times, and I'm going to need to use parentheses here. So the derivative of 2x would be 2 plus, and then this would be the derivative of y, which would be dy over dx, is equal to the derivative of x, which is 1 dx over dx, which is just 1, right? So 1 plus 0, so we don't need to write the plus 0, okay? What I would do is I would multiply both sides by this denominator, 2x plus y. So we get 2 plus dy over dx is equivalent to 2x plus y. And then what I would do is just subtract 2 from both sides. So dy over dx is equal to 2x plus y minus 2. Okay, and that's what dy over dx is. And 2x plus y minus 2, and that the correct answer would be B. So the correct answer is B. So number 19 is they give you the figure above shows the graph of the function g, the line tangent to the graph of g at x equals -1, and h is the function which is equal to e to the x times g of x. And they want to know what is the value of h prime of -1. Okay, now I'm going to tell you what we have to use here, because this is a product right here, is we got to use the product rule. Okay, so we know h of x is this. Okay, so h prime of x is equal to, okay, so the derivative of e to the x, which would be e to the x times, I'm going to put parentheses around here, e to the x times g of x, and then plus e to the x, that now I'm not taking the derivative, it's just e to the x, times g prime of x. Okay, and we want to find this at x equals -1. Okay, so h prime of -1. Okay, so this would be e to the -1 times g of -1 plus e to the -1, and then times g prime of -1. Okay, so we need this would be 1 over e. Okay, so this would be 1 over e times, and then g of -1. Now we're going to use the graph, right? Because this is the graph of g, and we know that at -1, g is 3, right? So this is 1 over e times 3 plus, and then e to the -1 is again 1 over e, and then times what's g prime of -1. Okay, so g prime of -1. Okay, so that is the slope of the tangent at -1. Okay, so that would be the slope of this tangent line, right? And we know this tangent line, okay, it's going through 0, -3, and it's also going through -1, 3, right? Because they have a little dot right there. Okay, so what you know, okay, is that we can find the slope for this tangent line, and that would be the slope of the that'd be the equivalent to the value of g prime of -1. Okay, so we're going from a y value of 3 to a y value of -3. So that's a decrease of 6, right? So we're going to do delta y over delta x, and it's going to be 3 minus -3. You could do this in your head too, okay? 3 minus -3 over, okay, so we're going to do 3 minus -3, and it's going to be -1 minus 0. So -1 minus 0. So that'd be 3 plus 3, which is 6 over -1. So that gives you a slope of -6. Okay, so that means g prime of -1 is equal to -6, right? Because that's where we found the tangent at, all right? So this would be times -6. So this would be 3 over e, and because we're adding and we're multiplying these two numbers and it's a negative, this is going to be minus 6 over e, which gives you -3 over e. And that would be, the correct answer would be B, okay? So B. Okay, so for number 20, I'm asking you to find the derivative of the integral from 0 to 2x of the natural log of t cubed plus 1 dt. Okay, so when you take the derivative of an integral, okay, if this isn't x, okay, we're going to have to apply the chain rule. So we're going to, when you take the derivative of an integral, you take this and you put it in for t, okay, and then times the derivative of this, okay, because you're putting into this function another function, all right? All right, so this is equivalent to the natural log of, and it would be 2x cubed plus 1, close the parenthesis, and then times the derivative of 2x, which would be 2. Okay, so cleaning this up, this would be 2 natural log of, and this would be 2x cubed, which would be 2 cubed x cubed, right? So that'd be 8x cubed. plus 1. Okay, and so the correct answer for that one is D. Okay, so the correct answer is D for that one. Let's go to 21. All right, first, so number 21, they're giving you the graph. It's linear lines, okay? And what is the value of the integral from 0 to f, or 0 to f, 0 to 7 of f of x dx, okay? So we're just going to use geometric shapes to figure this out, okay? So 0 to 7, we are going in the right direction because we're going from left to right, right? 0 to 7, f of x dx, okay? Now, you can do this a couple ways. I would probably break this up right here and right here. Okay, so I would break this up into a rectangle, actually 2 rectangles. Okay, so you have a rectangle here, a triangle, and a triangle, and then we also have another triangle right here. Okay, now we got to remember that when we do the integral, right, we can use areas to find that. Okay, if we're going from left to right, which we are because we're going from 0 to 7, any the integral is the same as the any where the functions above, the area and the integral are the same thing. Okay, so we're really gonna we're not gonna write this, but we're breaking it up in from 0 to 5 and then from 5 to 7. Okay, so remember we talked about this, the integral and the area are related, but they're not necessarily the same. Okay, because this has an area, but the integral from 5 to 7 has to be negative. Okay, all right, hopefully you remember that. All right, so this would be, this rectangle right here would be 2 times 1. And then we need to add 1/2, and this would be, this height would be 1 and this would be 2, so 1/2, 2 times 1. And then plus, then we gotta get this, and this looks like a square, right? So it's 2 going up and 2 going across, so it's 2 by 2. So 2 times 2, or 2 squared. All right, and then plus 1/2, and this would be 2 times 1. Okay, now in this case, because the function's above and we're also integrating from left to right, the area and the integral from 0 to 5 are the same. Okay, so the area and the integral are the same. All right, now the area and the integral are not the same from 5 to 7 because the area is positive, okay, but the integral has to be negative. So I'm going to write a minus. And here's why. I'm going left to right, so my delta x's are positive, but my function is negative here. Okay, so I'm multiplying. If you think about those rectangles, that we did with Riemann sums, okay, the delta x, the widths are positive, but now the function, the heights are negative, okay? So that's why I'm gonna have a negative here. And it's a triangle, so it's gonna be 1/2 times and 2 by 2, okay, 2 by 2. Okay, so this would be 2 plus, and half of 2 is 1 times 1 is 1, and this would be plus 4. And then this would be half of 2, which is 1, times 1 is 1, so plus 1. And then this is minus, okay, 2 times 2 is 4, and half of 4 is 2, so minus 2. So these two cancel out, and what you're left with is 1 plus 4 plus 1, which would be 6, and the correct answer would be A, okay? And so for 21, correct answer is A. Okay, for number 22, I pulled this up, okay, because there's a lot of information here. The function f is continuous for all real numbers, and the average rate of change of f on the closed interval from 6 to 9 is -3/2, okay? And for 6 less than c less than 9, there is no value of c such that f prime of c is equal to -3/2. Of the following, which must be true? Okay, this is actually testing your understanding of the mean value theorem, because if it's continuous on the closed interval and differentiable on the open interval, then this has to be true, right? So we have to know that there has to be, so f, like f of 9 minus f of 6 over 9 minus 6, okay, which would be, we know that this would have to come out, well, they're telling you that this is -3/2. Okay, and so that means that there has to be a derivative at some value of c in between 6 and 9 such that it's the same as this one, right? Because that's what this is saying. The average rate of change, and there has to be a derivative that are the same. That's what the mean value theorem tells us. But there's the conditions, right? And the conditions are that it must be continuous on the closed interval, okay? Well, they're telling you it's continuous, but it also must be differentiable, right? So why this wouldn't be happening is because it's not differentiable. So f is not differentiable on the open interval 6 to 9. It has to be that one, and there's no other one that it could be, all right? It has to be E, okay? So the correct answer to this is E, and it's really just, do you know the mean value theorem, okay? All right, and that's just saying that on a closed interval, okay, that there has to be a derivative that's the same as the average rate of change. This is the average rate of change. This is the derivative. And the x value where that derivative has to happen has to be somewhere in between the endpoints, okay? All right, so let's go to the next one, okay? So 23. Okay, so for 23, they're giving you the function f of x is 2x plus e to the x. And they're telling you g of x is the inverse of the function f, okay? For all x, and the point 0, 1 is on the graph of f, okay? So this right here is telling you f of 0 is equal to 1, because if you put 0 in, you get 1 out, okay? And they're asking you to find g prime of 1, okay? All right, so this goes back to Honors Math 3, all right? Because what you know is that if f and g are inverse functions of each other, right? F of g of x, and you can figure this out really quick. If these are inverse functions, then you're going to get out what you started with, which was x, right? So this allows us to figure out what the derivative of g prime is, okay? So to take the derivative of this, right, we're going to take the derivative of both sides. This is going to be 1, okay? So the derivative of this is going to be the chain rule. So it's f prime of g of x times g prime of x is equal to 1, which means g prime of x must equal 1 over f prime of g of x, okay? So this is going to allow us to find g prime of 1. So g prime of 1 is simply 1 over f prime of g of 1. Okay, we got to find g of 1. Well, we can, because if f of 0 is equal to 1, then that would mean g of 1 equals 0. Okay, so then that means this is 1 over f prime of 0. Okay, so now we have to find f prime at 0, right? But we got the function f, so we can do this, okay? So f prime of x would be 2 plus e to the x, because the derivative of e to the x is e to the x, right? All right. So that would be f prime of 0, right, is equal to 2 plus e to the 0. E to the 0 is 1, right? So this would be f prime of 0 is equal to 2 plus 1, which is 3. Okay, so this becomes 1/3. And the correct answer for 23 is B. All right. Okay, let's go to 24. So for 24, they're giving you the function g of x is equal to 4x cubed plus 3x squared minus 6x plus 1. And what is the absolute minimum value of g on the closed interval -2 to 1? Okay, so this is the closed candidates test, all right? So what you need to do is we need to check our endpoints here, okay? So we got to find the derivative. We got to find the critical values, and then we're going to put in the endpoints and the critical values and just take a look and see which one is the smallest. This is the candidates test, okay? Because this is a polynomial and we know it's continuous, right? So it's continuous on the closed interval, right? So it's going to have an absolute min and an absolute max, okay? Now we're only asking for the absolute minimum in this problem, okay? So let's first find g prime of x. So g prime of x would be, and this would be 12x squared plus 6x minus 6. Very nice, because these are all divisible by 6, so we can factor a 6 out, okay? So g prime of x would equal 6 times, okay? And this would be 2x squared plus x minus 1. Okay. Now we need to factor this, okay? So g prime of x is equal to 6, okay? And you can use an area model for this. So we're looking for a product of -2 and a sum of 1, right? Product -2 and the sum needs to be 1, right? So that would be 2 and -1. All right, so we can do our little area model. And we know that this is 2x squared, and we know this is -1, and this one of these would have to be 2x and the other one would have to be -1x. GCF across the top would be 2x, then this would have to be x, and this would be -1, and then this would have to be +1, and 1 times negative, so we're making sure 1 times -1 is -1. Okay, so this factors into 6 times 2x minus 1 times x plus 1. Okay, now we're going to set that equal to 0 and find the critical values, right? So these are going to be horizontal tangents, right? That's what we're finding, the x values at which horizontal tangents happen. So this would be 0 is equal to 6 times 2x minus 1 times x plus 1. Okay, so this would happen when x is equal to 1/2 and also when x is equal to -1. Okay, so now we got to put these back into our function. Okay, so this is going to take a little bit of work, and you on on this test there, you didn't have a calculator, but on the RAP exam you get to use a calculator on the entire thing. Okay, so this would be g of -2. We got to find that one. We got to find g of -1. Let's do. I'm going to do these in order. So g of -1, and then g of 1/2. That's the one I'm not looking forward to doing. Okay, g of 1/2, and then g of 1. And then we're just going to look and see which one's the smallest, right? Because they're asking for the absolute minimum. Okay, so this would be 4 times -2 cubed plus 3 times -2 squared minus 6 times -2 and then plus the 1. Okay, so this is going to be -8 times 4, which would be -32. And this would be 4 times 3, which is +12. And this would be +12. And then plus 1. Okay, so this is +24. So that with a -32 would make -8. And then plus 1, which would be -7. And then g of -1, that would be 4 times -1 cubed plus 3 times -1 squared minus 6 times -1 and then plus 1. Okay, so this would be -4. This would be plus 3 plus 6 plus 1, right? So this would be, these two together makes -1 with this one cancels, and so you're left with 6. And then g of 1/2. Okay, so that'd be 4 times 1/2 cubed plus 3 times 1/2 squared minus 6 times 1/2 and then plus 1. So this would be 1/2 cubed is 1/8 times 4, so that'd be 4/8, which is 1/2. And 1/2 squared would be 1/4, so this would be plus 3/4. And this would be minus 6/2, which would be -3. And then plus 1. Okay. This is 2/4. Okay, which with this would make 7/4 minus 2, because -3 and +1 make -2. Okay, so this would be -1. This would be -8/4. So -8/4 and 7/4 makes -1/4. And then g of 1. Okay, so g of 1 is 4 times 1 cubed plus 3 times 1 squared minus 6 times 1 plus 1. So this would be 4 plus 3 minus 6 plus 1. Okay, so this would be 7 minus 6, which is 1, and 1 plus 1 is 2. So which one's the smallest of all of these? Okay, and it would be negative 7, right? And so the correct answer for this is A. All right, okay, let's go to 25. All right, for number 25, we know that dy over dx is equal to e to the y plus x power. And we also know that y of 0 is equal to negative natural log of 4. All right, so we need to rewrite this because right now this is separation of variables. It's a differential equation, but I need to rewrite this, okay? So e to the y plus x power can be rewritten as dy over dx is equal to e to the y times e to the x power, okay? All right, so now then we can separate them, right? Because we're multiplying, okay? So we got to get our y terms, our e to the y on this side, on the left-hand side, and our dx on the right-hand side. So I'm going to multiply both sides by 1 over e to the y, okay? So that would give me 1 over e to the y dy is equal to e to the x dx. Okay, I'm going to integrate both sides. So that's the integral of 1 over e to the y dy is equal to the integral of e to the x dx, okay? This needs to be rewritten as e to the negative y dy, and I'm going to integrate that, right? And this equal to the integral of e to the x dx. Now I'm going to do a u substitution, okay? So I'm going to let negative y be u. So u is equal to negative y. Du would be equal to negative dy. So I need to pick up a negative here, right? So this is going to be negative integral, okay, of e to the negative y times negative 1 dy is equal to, because that's really still e to the negative y dy, okay, because these two negatives would cancel each other out and make a positive 1. So I shouldn't say cancel. They multiply to give you positive 1. And then the integral of e to the x dx. All right, so then this becomes negative integral of e to the u power du is equal to the integral of e to the x dx. And now we're ready to integrate, okay? So this is going to become just simply negative e to the u power is equal to e to the x plus some constant c, okay? And this u gets switched back to negative y. So this is negative e to the negative y is equal to e to the x plus some constant c. Okay, so then the next thing that I would do is I would probably, you can either start solving this for y. I think it's going to be easier if we get what our c is first, okay? So I know if I, from this initial condition, okay, because this is an initial value problem, okay? If I put 0 in for x, I'm going to get out negative natural log of 4 for my y. So that makes negative e to the negative of negative natural log of 4 is equal to e to the 0 plus c, okay? So this becomes negative 1 times e to the natural log of 4 is equal to, and then e to the 0 is 1 plus c. E to the natural log of 4 just becomes 4. So this is negative 1 times 4, so negative 4. I'm going to slide it up a little bit, okay? So negative 4 is equal to 1 plus c, and then I'm going to subtract 1, and I get negative 5 is equal to c, okay? So I'm going to come back into this right here where this equation where I have x and y in the equation, and this becomes negative e to the negative y is equal to e to the x and plus negative 5, but that's really the same thing as minus 5. Okay, now I think it's easier if we multiply both sides by negative 1, okay, and get rid of this negative right here. Okay, so this is e to the negative y is equal to, this would be negative e to the x and then plus 5. I think probably a better way of writing that is 5 minus e to the x. So this is e to the negative y is equal to 5 minus e to the x. And then what I'm going to do is I'm going to take the natural log of both sides, okay? So this becomes the natural log of e to the negative y is equal to the natural log of 5 minus e to the x, okay? And then these are going to undo each other, so you're going to be left with negative y is equal to the natural log of 5 minus e to the x. And then what you're going to do next is you're going to multiply both sides by -1, and you'll have what y is. Okay, so y is equal to negative the natural log of 5 minus e to the x. Okay, and you look, and it's slightly different, but it's actually c, right? So y is equal to negative natural log of negative e to the x plus 5, right? Okay, so I switched it around. You didn't have to. Okay, so the correct answer is C. So negative, and they have it in your answer sheet, negative e to the x plus 5, which is the equivalent answer to this, okay? All right, so the correct answer is C, okay? Let's go to 26. All right, so for 26, okay, which of the following is an antiderivative? Okay, so integrals are antiderivatives, right? So if we take the integral, okay, of both sides, okay, and we actually can't take the integral of this, and you guys don't have the techniques able to do this, okay, but if you look, some of these are integrals, right? So this kind of looks the same, right? Okay, so you can create a function that's the antiderivative simply by writing an integral function, okay? So if we take the integral from 0 to x of f of t dt, that's going to be the antiderivative of this, okay? So that means this just is simply the integral of 0 to x of the square root of 1 plus t cubed. Remember, we have that dummy variable, dt. So it has to be this one, part E, okay? So the correct answer is E. So for 27, they're asking you to find, they're giving you this function for the spring suspended, the height of an object suspended from a spring, okay? They're giving you the height function, okay? And it's 16 plus 7 cosine of pi t over 4. And then what is the average height? So this is the function, right? H of t is the height, and they're asking you to find the average height. So this is the average value of a function from t equals 0 to t equals 2, okay? So really, this is just simply the 1 over 2 minus 0 times the integral from 0 to 2 of h of t dt, okay? And so that would be 16 plus 7 cosine of pi t over 4, and then dt. Okay, so this becomes 1/2 the integral from 0 to 2 of 16 plus 7 cosine of pi over t, pi times t over 4 dt. Okay, now what we're going to do is I'm going to break this up into two separate integrals, okay? So this is going to equal 1/2 the integral from 0 to 2 of 16 dt. I think this is going to be easier if we do it this way, okay? And then plus 1/2 the integral from 0 to 2 of 7 cosine pi t over 4, and then dt. Okay, so this is going to be 16t. So this is going to be 1/2 times 16t evaluated from 0 to 2. And then plus, and then this one's, I'm going to bring the 7 out. So plus 7/2 the integral from 0 to 2 of cosine of pi t over 4. Okay, so the reason I did this is I didn't need to use a u substitution here, but I do need it here. Okay, so I'm gonna let u equal pi t over 4. Okay, and then du would be pi over 4 dt. Okay, so I need a pi over 4. That means I need to multiply out here by 4 over pi. Okay, so this is going to become 8t. Okay, so 8t evaluated from 0 to 2. I'm holding off on that. And then plus, okay, and then I'm going to need pi over 4 dt, so I'm going to need to multiply by 4 over pi to get that. So 7 pi over 8 evaluated from 0 to 2, okay, cosine of pi t over 4 times pi over 4 dt. Okay, so this is pi over, I made a mistake here. Okay, so let me backtrack this. Okay, so this I need to multiply by 4 over pi because I needed pi over 4 over pi. So let me fix this right here. Okay, so 4 over pi, then that would make this one 7 times 4, which is 28 over 2 pi. Okay, so because I multiplied by 4 over pi to get pi over 4 here. Okay, remember I have to multiply by the reciprocal. Okay, sorry about that. All right, okay, so now I can do my u substitutions. Okay, so this is, I'm going to go ahead and do this one. So this would be 16 minus 0. So this is just 16. Okay, and then plus, and then we have this 28 over 2 pi. The integral of, this is going to be cosine of u du. Okay, and then this 0, remember I got to change these to u's. So this 0 is going to stay 0. And then when I put 2 in for my t right here, okay, it's going to be pi times 2 over 4, which is pi over 2. Okay, so now I'm going to be able to integrate this. Okay, so this is 16 plus 28 over 2 pi, or you could reduce this to, this is 14 over pi. Okay, and the derivative of sine is cosine, so the integral of cosine would have to be sine. So this is sine of u evaluated, and I should put brackets around this, from 0 to pi over 2. Okay, so then this is 16 plus 14 pi sine of pi over 2, and then minus 14 over pi sine of 0. Now sine of 0 is 0. Okay, so this is going to be 0 right here. So we're left with 16 plus 14 over pi. Sine of pi over 2 is 1, so times 1. So this turns out to be 16 plus 14 over pi. Okay? And so the correct answer for number 27 would be D. Okay, so for number 28, they're giving us the function f of x is sine x plus cosine x, and they're telling us 0 is less than or equal to x, which is less than or equal to 2 pi. That's going to be helpful, okay? And then what they're asking us here to do is we want to figure out the x coordinate of the point of inflection where the graph of f changes from concave down to concave up, okay? So to determine concavity, I'm going to have to use the second, find the second derivative of this, okay? So the derivative, okay, so the derivative of sine x would be cosine x. And then the derivative of cosine x would be negative sine x, so minus sine x. Okay, now I got to take the derivative of that. So the second derivative, f double prime of x, the derivative of cosine x is negative sine x. And then minus the derivative of sine x is cosine x, okay? All right. Okay, so now we're only looking from 0 to 2 pi, okay? So now we got to find the critical values, okay? So these are the x values where the second derivative is either 0 or undefined. Okay, so sine x and cosine x both are neither of them are going to be undefined, okay? So you're fine with all of this, okay? So what we're going to have to do is we're going to set this equal to 0. So 0 is equal to negative sine of x minus cosine of x. Okay, and so how do you solve this? Okay, so this is something I taught you at the end last year, okay, in trigonometry, okay? When you have sine x and cosine x and a subtraction or addition like these, okay, and it's equal to 0, what we're going to be able to do is move one of them over, okay? So we can move, I'm going to move the sine x over, so we get sine x would have to equal negative cosine x. Okay, and then what I'm going to do is I'm going to divide both sides by cosine x. Okay, so I would get sine of x over cosine of x would equal negative cosine of x over cosine of x. Okay, now sine x over cosine x, so, because here's the thing, we need to make this be one trig function, okay? So sine x divided by cosine of x, that's a trig identity, that's tan x. And negative cosine x over cosine x is negative 1. Okay, so where is between 0 and 2 pi, where is tan x equal to negative 1, right? So remember, this is negative 1 over 1, right? So for it to be 1, my y and my x both have to be 1, okay? And one of them is negative 1 and one of them is positive 1. So that's going to happen here in the second quadrant, because right here, my y would be 1 and my x would be negative 1. But then down here in the fourth quadrant, my x would be 1, but my y would be negative 1, right? So my reference angle is pi over 4, and here my angle is pi over 4, but my angle of rotation would be this one, which would be 3 pi over 4, okay? So for this, x would equal 3 pi over 4. Or if we keep going, okay, if we go all the way around to here, that'd be 8 pi over 4. So this would have to be 7 pi over 4. So this is going to happen at 3 pi over 4 and 7 pi over 4. Okay, so we're going to do a sine chart, okay? So we're going to do our intervals. And this would be from 0 to 3 pi over 4. And then from 3 pi over 4 to 7 pi over 4. And then from 7 pi over 4 to 2 pi. Okay, and we're going to do test points. Okay, so right in here, okay, 3 pi over 4, I think a good one to put into our second derivative would be pi over 2. Between 3 pi over 4, 3 pi over 4, and 7 pi over 4, how about pi? Because pi would be 4 pi over 4, right? And then from 7 pi over 4 to 2 pi, there just really isn't a good one there, okay? So let's try x is equal to, let's say, really the only one you could do is 11 pi over 6. Okay, so now we're going to find the sine of f double prime. Okay, so I'm going to do a little bit of work right here, okay? Okay, so we know we got to find f, we got to actually find the value here. So f double prime of pi over 2. So that'd be negative sine of pi over 2 minus cosine of pi over 2. Well, we know sine of pi over 2 is 1, so this would be negative 1, and then minus, and then cosine of pi over 2. Cosine of pi over 2 is 0, so minus 0, so that'd be negative 1. So this is negative, okay, which tells you it's concave down. Okay, how about at pi? So f double prime at pi. Okay, so that would be negative sine of pi minus cosine of pi. Okay, so that'd be negative of sine of pi would be 0, and cosine of pi would be negative 1. So that'd be minus negative 1. So that would be 1, which is positive, right? So that'd be positive. Okay, now let's see if we can answer the question right here. Okay, so what is the x coordinate of the point of inflection where the graph of f changes from concave down to concave up? This is concave down to concave up. It's going to be x equals 3 pi over 4. Okay, now I want to do this because we're not going to have multiple choice, so I want to finish this off. Okay, this is a really good problem that they might ask you on the exam this year. Okay, because it's not one that you can just look up really quick and find this. Okay, all right, so f double prime of 11 pi over 6. Okay, and so that would be negative sine of 11 pi over 6, and then minus cosine of 11 pi over 6. Okay, so I'm going to draw a diagram for 11 pi over 6. 11 pi over 6 would be right here in the fourth quadrant. Okay, this is pi over 6, so that would make this negative 1. This would be 2, and this would have to be positive square root of 3. Okay, so this is negative, and then sine of 11 pi over 6. Sine of 11 pi over 6 would be negative 1 over 2. And then minus cosine of 11 pi over 6. And I don't need the cosine because I'm going to find it, right? Cosine of 11 pi over 6 is the square root of 3 over 2. Okay, so this is 1/2 minus the square root of 3 over 2. Okay, so here's the thing, and so this is 1 minus the square root of 3 over 2. Now, what we have to determine, is this going to be negative or positive, okay? So which of these is bigger? Is 1 bigger than the square root of 3, or the square root of 3 bigger than 1? Well, the square root of 3 is bigger. So we're going to do 1 minus a bigger number. This is going to be negative. And 2 is positive, so that means this is going to be negative. Okay, so what does that tell me about the behavior of f? Okay, so the negative tells me it's concave down, then concave up, and then concave down. Okay, so concave down, concave up, concave down. All right, and that means there's an inflection point at 3 pi over 4, and there's also an inflection point at 7 pi over 4. But the question asks you, when is the inflection, what's the x coordinate of the point of inflection where f changes from concave down to concave up, and that would be at x equals 3 pi over 4. So the correct answer for 28 is B, okay? B. All right. So you guys, that's it for the multiple choice. I know on these days, the first part is going to be long, okay? So I already know how long this video is. It's pretty long, okay? So if you get, here's the thing. If you get them right, just fast forward through them, okay? I should have told you that at the beginning. Just, if you got it right, fast forward, okay? No reason to sit there and listen to something that you already know is correct, okay? All right, so you guys take care, and I will see you for the next lesson.